Welcome to the video lecture for section 3.1. This is measures of center, and this is for statistics, STA 2023, and my name is Jorge Garrian. So this particular lecture, I'm going to go back and forth between the PowerPoint and the Excel file, so it'll be a little longer than usual. And so one of the key concepts, the focus of this section, is we're going to obtain a value that measures the center of the data set. So in particular, we're going to present measures of center. We're going to talk about the mean and the median. And so the objective here is not only to find the value of each measure, but also to understand what those values mean in context of the data set. And that's what I always try to emphasize in this course when I teach it. So the first thing, measure of center. A measure of center is simply a value at the center or the middle of a data set. So the mean of a set of data is a measure of center found by adding all of the data values and then dividing the total by the number of data values. So you found, in other words, the average since grade school. And so now we're going to sort of have a formal definition of what it is. Now in statistics, we don't call it the average, we call it the mean. So just be aware. Sometimes I do interchange them, but we tend to stick with mean most of the time. So some important properties of the mean. Sample means drawn from a sample population tend to vary less than other measures of center. Now the mean of a data set uses every data value. So one of the disadvantages of the mean is that just one extreme value, an outlier, can change the value of the mean of the data set substantially. And so using the following definition, we say that the mean of a data set is not resistant. And so an example would be if we take the average age of a high school class, let's say it's turns out to be 16, but then we include the teacher, then that's going to pull the mean up because the teacher is much older than the students. So what do we mean by resistant? A statistic is resistant if the presence of extreme values, outliers, does not cause it to change very much. Now, before you can determine or denote something as an outlier, there is a calculation to figure out whether or not it is actually an outlier. So some notation. The first one is sigma, just simply denotes the sum of the set of data values. X is usually the variable used to represent the individual data values. Lowercase n represents the number of data values in the sample, and uppercase n represents the data values in a population. So when you see that sigma, it just means that you're going to add up whatever that is. And so here's the formula for sample and population mean. X bar is obviously pronounced X bar is the mean of a set of sample values. So X bar is equal to the sum of X divided by N, which is the sample size. Mu is the mean of all values in the population. So mu is equal to the summation of X divided by the population size. And so you can see that the formulas are identical, but some of the symbols that we use are different. So here's an example, and I will be going to Excel after this one, and I will provide this data set to you guys. So this includes a measure of data speeds of smartphones from 4 different carriers. So we're going to find the mean of the first 5 data speeds for Verizon. And so when we do that, we find out that is actually 30.74 megabytes or whatever it is that thing stands for. So X bar is equal to the summation of X over N. So you can see how they took all of the first 5 values, and I'll show you that in a second, and divided by 5, we got 30.74. So how do we do that in Excel? So here's the data set. Here's the Verizon. So we're going to look at the first 5. And the first thing we're going to do is we're going to find the mean. And of course, if you recall that we did get 30.74. So probably one of the ways that you can find it, and I will show you a different way in class, is you start typing equal average. And you can see here, I get the average. I just highlight all of my data points, and I press enter. Now, if you notice, I did get 30.7. Now, we always want to go 1 decimal place more than our raw data. So that what I'm going to do here is simply change this from 1 decimal place to 2. And then I get my 30.74. Let me go back here. So some things about the mean. We never use the term average. I kind of spoke about that a little bit. So the word average is often used for the mean, but is sometimes used for other measures of center. So the term average is not used by statisticians, and the term average is not used by statistics community professional journals. So if you read a journal article, they'll say the mean. The next thing we're going to talk about is the median. So the median of a data set is simply the measure of the center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. So you can do it from the largest to the smallest or smallest to the largest. We tend to do smallest to largest. The nice thing about technology is that we don't really have to do that. So some important properties of the median does not change by large values when we include just a few extreme values. So the median is resistant measure of center. And the median does not directly use every data value. For example, if the largest value is changed to a much larger value, the median does not change. And it doesn't change because it doesn't change the number of data points. And so this is what I was talking about, the data points. The median of a sample is sometimes denoted by x tilde or capital M. Now, to find the median, we first sort the values. We arrange them in order. So now, if the number of data values is odd, then the median is the number located in the exact middle. And if you think of 5 data points, I'll have 2 to the left and 2 to the right, and I'll have it by itself. Now, if the number of data values is even, the median is found by computing the mean of the 2 middle numbers in the sorted list. So again, 6 values, I'll have 3 and 3. So I'll have to take the 2 middle ones, add them together, and divide it by 2, and that's going to be the median for that particular data set. So the median, I can change a value, but it's not going to change that statistic because I didn't change the number of data points. And so we're going to go ahead and find the median for the first data speeds for Verizon. And so you can see that we get 23.1. So because there are 5 data values, a number of the data values in odd numbers, the median is located in the exact middle. And so how do we do that using Excel? We can actually type in equal median. You double click, just highlight your points, and we get 23.1. Now, what happens, we're going to repeat the process, but now we're going to have 6 points. And so when we do that, we actually get a different value. We get 23.8. So you can see here that previously, without this 55.6, the middle value was a 23.1. But now we added this extra data point, and so now we have 3 and 3. So since it's an even number, we'll take the 2 middle ones and we'll add them and divide them by 2, and that's going to be our median. And so if we were to do that in Excel, the process is the same. Just highlight them. I think we added the 24.5. I apologize for that. So we get 23.8, which is exactly what they got here. Now the next one we're going to talk about is the mode. So the mode of a data set is the value that occurs with the greatest frequency, or the one that occurs the most often. So the mode can be found with qualitative data. We can't find a median and a mean for qualitative data. That doesn't make any sense. Now a data set can have no mode, one mode, or multiple modes. So how do we find a mode? A data set can have one mode, more than one, or none. When 2 data values occur with the same greatest frequency, each one is a mode, and the data set is said to be bimodal. If we were to graph that, we'll have 2 peaks. When more than 2 data values occur with the same greatest frequency, each is a mode, and the data set is said to be multimodal. Now, when no data value is repeated, we say that there is no mode. So here's an example. I won't do this in Excel, but here's an example of find a mode of the sprint data speeds. And you can see here that 0.3 occurs the most often. So 0.3 is the mode for this particular data set. So another one, here's 2 modes. So you can see here that 0.3 and 4 occur with the same frequency. And in the second example, there is no mode because no value is repeated. The next one we're going to talk about is the mid-range. Now the mid-range of a data set is the measure of center that is the value midway between the max and the min values in the original data set. It is found by adding the max data value to the min data value and then dividing by 2. So here's the formula for mid-range. Is the max data value plus the minimum data value divided by 2. And so now, because the mid-range only uses the max and min, is very sensitive to these extreme values, so the mid-range is not resistant. Now in practice, the mid-range is rarely used, but it has some features that are good. It's easy to compute. It helps to reinforce the very important point that there are several ways to define the center of a data set, and the value of the mid-range is sometimes used incorrectly for the median, so confusion can be reduced by clearly defining the mid-range along with the median. So here's an example of finding the mid-range. So here are our 1, 2, 3, 4, 5. So these are the 5 points. So we take the max and the min, add them, and divide them by 2. So what I'm going to do is I'm going to go to the Excel file and show you how to do that. There isn't a key to do that, but we can do this the way we found the midpoints, really. So what's going to happen here is, before I do this, is I'm going to want to order these from smallest to largest, and there's a way that I can do that simply by going to filter, and I'm going to sort from smallest to largest. And so you can see here that it did that for me. So it put it from the smallest to the largest. None of my values change. And so the mid-range now will be a little easier to calculate. So it's going to be, and honestly, since I'm adding, it doesn't really matter if I do the min first or the max. So I get 34.85, which is exactly what we got, or the PowerPoints got. So some round off rules. For the mean, median, mid-range, carry one more decimal place that is present in the original set of values. For the median, since it comes directly, if it's an odd number, it comes directly from the middle point. I don't tend to do that. If it's an even number of data points, then you will have one more because you are finding the mean. For the mode, leave the value as it is without rounding. So some critical thinking, we can always calculate measures of center from a sample of numbers, but we should always think about whether it makes sense to do that. We should also think about the sampling method used to collect the data. So here's some critical thinking and measures of data. So each of the following illustrating situations in which the mean and median are not meaningful statistics. Just because they're values doesn't mean that they're going to be meaningful to find the mean or the median. So zip codes of the Gateway Arch in St. Louis, White House, Air Force Division of the Pentagon, Empire State Building, and Statue of Liberty. So the zip codes don't measure anything, or they don't count anything. They're simply labels for geographic location. So finding the mean and the median of these values is insignificant. The next one, ranks of selected national universities. You have Harvard, Yale, Duke, Dartmouth, and Brown. Again, the ranks, they just reflect an ordering. So measuring, they don't measure or count anything insignificant to try to find the mean or the median. Next thing we're going to talk about is frequency distribution. So we've learned how to construct a frequency table. And so we can actually find the mean of, once we group everything, this is also called group mean. So once we group it into classes or categories, we can actually find the mean. Now this is an approximation because we do tend to use the midpoint as opposed to the actual values. But the formula for X bar is simply the summation of the product. So what I do is I multiply the frequency times the midpoint for each class, and I divide it by the total number of data points, or the sum of the frequencies, which is the same thing. So when we do the mean from a frequency distribution, the first column is going to be our classes. It doesn't matter if you use class limits or class boundaries. We have the frequency, we have the class midpoint, and then we have the last column, which is the product of the frequency and the midpoint. So you can see at the bottom of the table, we have the summation of F, which is just how many data points we have, which is 50. And then the last column, we have the summation of the product of F and X, which in this case happens to be 8,025. So when you find the mean of the frequency distribution, these are the two most important columns that you need. Now, once you do that, what happens is that you just simply divide them using the formula. So this is simply an approximation because it's based on the use of class midpoints, like I said before, instead of the original list of service times. So let me go ahead and go to Excel so I can show you that. And so I'm going to go ahead and just redo all of this here so you guys can see it. And so the only thing, all of this is available to you. We've done this previously in class. So the first thing that I'm going to do is, of course, I want the summation here. I want that summation of F, which in this formula is my denominator. And now I'm going to calculate my numerator so I'll be able to finish it off. And so here I'm just going to go ahead and do equal. I'm going to do the frequency times the midpoint. And then I'm just going to go ahead and drag it, right? I don't have to do it multiple times. So my summation for this particular example is 7,989. My data points are 50. And then the mean is just simply I divide this value by this value. So let me show you how to do that. So I take this cell here, divided by this cell. And of course, if you recall back, the textbook went up to 50 when they created the width. I stayed at 46, so that's why our values are slightly different. The next thing we're going to talk about is weighted mean. So in different x data values that assign different weights, we can compute a weighted mean. So x bar for a weighted mean is equal to the summation of w times x divided by the summation of w. So if you notice, the formula tends to be the same. This formula is similar to the frequency distribution formula. So here's an example. In the first semester of college, a student of the author took 5 courses. Her final grades, along with the number of credits for each course, were the following. So it was A, it was a 3-credit class. She got an A, a 4-credit class. She got a B for a 3-credit class, a C for a 3-credit class, and an F for a 1-credit class. So the grading system assigns quality points to letter grades as follows. So A is a 4, B is a 3, and so on and so on. So we're going to go ahead and compute her GPA. So the number of credits, that's weight. So here, of course, the weights would be the number of credit hours, so or credits for the course. So 3, 4, 3, 3, and 1. So we're going to replace the letter grades of A, B, C, and F with the quality points, which is 4 for an A, 3 for a B, 2 for a C, and 0 for an F. And we take that information and we find the mean. So again, what this means is that I'm going to take the first weight times the first quality point, which is this, multiply that. I'm going to do that for each class per se, and then I'm going to add those up and divide it by how many I have total. And so this just means the summation of the products. And so let's go to Excel so we can see how that works. So again, here's my grade. Here's the weight for the grade, the quality point for that. Here's my W times X. Again, all I have to do is just multiply those. I'll make all this available to you guys. And so I can just go ahead and drag it. So my summation would just be 43. And so I'm going to do 43 divided by 14 to find my GPA. And this is just a repeat of the formula, right? I'm just using the formula. And so since I have no decimal points here, I can go to 2 decimal points. If I go to 1 decimal point, it'll be a 3.1. When we calculate GPA, we tend to go at least 2 or 3 decimal places. So here what I'm going to do is I'm just going to go ahead and go 3 decimal places, and then you can see that my GPA is 3.071. Now, they did round, right? And so I'm not going to round to 3.1. When I do GPA or something like that, usually the standard practice is to go to at least 2 or 3 decimal places. And that's the end of 3.1. Thank you.